Hi students, my name is Oladele. I'm your physics tutor. Today we want to look at simple harmonic motion. The topic simple harmonic motion is the periodic motion, the to and fro motion of a particle or of a body about a main position, that is the center or the middle of the motion, such that the acceleration is always directed towards the main position and the acceleration is proportional to the displacement. Simple, very simple definition. Simple harmonic motion. By definition, it is the periodic motion, that is the to and fro motion of an object, the to and fro motion, the periodic motion of an object about the main position, which is the equilibrium position, that is the center, the midpoint, such that the acceleration is always proportional to the displacement and it is always directed towards the main point. Simple harmonic motion. The acceleration proportional to the displacement and it is always directed towards the center, that is towards the main position. Simple harmonic motion. This is very similar to the oscillatory type of motion, the to and fro motion of an object, of a body, moving forward and backward about a particular position. Let's have a sketch of bodies performing simple harmonic motion. Take a simple pendulum, Give a simple pendulum, give it a small displacement. It performs the to and fro motion. Point A, point B, point C. The simple pendulum performs the to and fro motion about the main position. The main position here is the point B. That is the main position. At every point in time, the simple pendulum will always be moving, passing through point B, forward and backward. And the motion is always directed towards the main position. That is, the acceleration is always directed towards the main position. At every point, it is moving to and fro. That is simple harmonic motion. Very easy to understand. Simple harmonic motion, a periodic motion. The periodic motion of a particle, of an object, about a main position, which is called the midpoint or the center, such that the acceleration is directed towards that point, that is the main position, and the acceleration is directly proportional to the displacement. That is the displacement x. We have terminologies used in simple harmonic motion. First, we want to look at what we call the amplitude. We want to look at the frequency. We want to look at the period, and we want to look at the speed, all right? The amplitude here talks about the maximum displacement about the main position. That is the amplitude. Let's take the sinusoidal movement of the body about the main position. The amplitude, that is the maximum displacement from the main position. That is the amplitude. The maximum displacement from the main position. Frequency talks about the number of oscillation we have in a second. The number of complete oscillation in 1 second. What do we mean by a complete oscillation? Look at the sinusoidal graph. The body is moving from the origin, moving forward, the positive part, to the negative part, and coming back to the main position. That is a complete oscillation, a complete motion. From point A, the body moves through B to C, and back to point A. That is a complete oscillation. So the number of complete oscillation made in 1 second is what we call the frequency. Well, we can give it as n over t, the number of oscillation completed in a second. N over T. N gives the number, and T is the time. Period. Period is the time for one complete oscillation. That is the time to make a complete oscillation. Time for one complete oscillation. The time it will take this body to move from point A through B to C and back to A. And we can give it as T over N. The time for one complete oscillation. The time for one complete oscillation. The speed is the displacement of the body per unit time. The displacement per unit time. Displacement per unit time. Let's go over it again. I started by defining simple harmonic motion. What is simple harmonic motion? It is the periodic motion of a body or of a particle such that the acceleration is directed towards the center and the acceleration is directly proportional to the displacement. The displacement here is x, the displacement. And what we have here, minus omega squared, is the constant of proportionality. The constant of proportionality. The minus there, the sign there shows the direction. It's only telling us about the direction. Then we talked about the amplitude. What is amplitude? The maximum displacement from the main position. The maximum displacement, the highest displacement from the main position. Amplitude can be measured in meters. Frequency, the number of complete oscillation in 1 second. It is measured in hertz. We call it hertz. H-A-R-T-Z. So hertz. We use Hz. Hertz. Frequency. And period, the time. Time for one complete oscillation. Time is measured in seconds. Time in seconds. And speed, the displacement per unit time. The displacement per unit time. Now looking at this oscillation, take the simple pendulum as our guide. Let's look at what we mean by the end of the motion, the middle of the motion, and we want to consider the acceleration and the velocity at the 2 points. Listen again. The motion of this pendulum from point A through B to C. We have what we call the end of the motion. We have point A and point C. Those are the ends of the motion. Point B gives the center, that is the middle of the motion. So we have one end and another end. Point A and C, they are the extreme ends of the motion. While point B gives the middle of the motion. At point A, we can determine the acceleration of the body. We can also determine the velocity at point A. Likewise, point B, we can also determine the acceleration, which is the midpoint, and we can also determine the velocity at point C. Acceleration minus omega squared multiplied by the displacement, and the speed, the displacement per unit time. Omega is the angular frequency. All right, so the omega is the angular frequency, that is the angle turned per unit time, while the speed is omega multiplied by r. Omega multiplied by r. Likewise, we can give the speed as omega square root a squared minus x squared. Omega square root of a squared minus x squared. And omega, what is omega? Omega is 2 pi f, and it is 2 pi divided by t. Why are we having this? Frequency and period, they are reciprocal of each other. Frequency is the reciprocal of period. So I can replace my frequency with t. So omega is 2 pi divided by the period. So with this, we can attempt questions on simple harmonic motion. Definition, it is the periodic motion about a mean point, and acceleration is minus omega squared by x, which is the displacement, the velocity omega r, and velocity omega square root of a squared minus x squared, where omega is 2 pi f. F is the reciprocal of period 1 all over t. F is the reciprocal of period 1 over t. In other words, omega can be 2 pi divided by t. Now let's go to standard question. Standard question on simple harmonic motion.